So now we need an initial guess, x naught. Right? So x naught, initial guess should be something reasonable. We know if you put 3 in here, right, it's going to be smaller than root 10, right? 9 minus 10 would be negative. So, that'd be less than this right-hand side. If I put in the number 4, which is, of course, greater than root 10, we'll get 16 minus 10 is positive. That's greater than the right-hand side. So therefore, I'm going to start with being a little bit over the solution of root 10, and I'm going to guess the number 4. I'm going to start with number 4. Okay? That's the closest integer to the right of this root. Okay, so we'll start with 4. That's my initial guess. I don't need to do any computations. There's my initial guess. And now we will use that as the catalyst in Newton's formula. Okay? So we'll put 4 in to this formula here and see what we get out. Okay? So x1 is going to be 4 squared plus 10 over 2 times 4. So you have 16 plus 10 is 26 on 8. 26 on 8 is what, 13 quarters? Right at the decimal for that, it's pretty obvious, should be 3.25. All right, so we went down a little bit from 4, our initial guess, to 3.25, which is certainly closer to the root of 10. But it's probably not within 4 decimal places because this truncates it, or terminates, I should say, at 2 decimal places, so we need to go a little bit further. So x2. x2 will be this value. I'm not going to use the decimal, I'm going to use the ratio here, 13 fourths. 13 fourths squared plus 10, right? Just reusing the exact same formula with 13 quarters, our second result here. I'm counting this one as the first one in a sense, into that Newton function. So 13 fourths times 2. All right, simplifying a tad, we'll have 13 squared is 169, so 169 on 16 plus 10 over, and cancel this 2 with this 4, we'll be left with 13 halves in the bottom. 13 halves. All right, I'm going to try to simplify this a little bit. So we'll multiply this by 16 over 16. So we'll get 169 plus 160 over 16 times the reciprocal of the bottom, so 2/13. Here's a little bit further. Cancel that, get an 8 here. 169 plus 160 is 329. So we have 329 on what? 8 times 13? Now, neither 13 nor 2, right, which is a factor of 8, the only factor of 8 it has actually is 2. So neither 13 nor 2 go into 329. That's pretty obvious, I think. So I should just multiply this out. So we'll have 329 on, I think, 104. So 104 there. All right, there's our next approximate. I'm not going to bother to divide this out and write out the decimal. You can do that, or you can use a calculator, whatever you want to do, but I have a feeling the way Newton's formula converges, or the Newton function converges to the root, sorry I didn't see that, to the root of 10, it's going to converge to the root of 10. I know something about the rate of convergence of this Newton function. Therefore, I don't think we've reached 4 decimal places yet. Okay, but you can check it. If we have, then we should stop here if we reach 4 decimal places of accuracy. But I don't think so. So I'm going to go one more, and you can compare that one. And I bet that one will be at least 4 places of accuracy. Okay, so we need to do it one more time. It's going to be a little more cumbersome because the numbers are getting large now. So x3, we're going to have 329 on 104 quantity squared plus 10. Try to move through this quickly, but again, the numbers are getting large. And then the bottom will be 2 times that 329 on 104. All right, so we have 329 squared up there. That's big. So just to simplify a little bit first, 329 squared over 104 squared. So it'll be 10 times 104 squared over 104 squared. Not mistaken. And then I can cancel this a little bit, and this will be a 52, it looks like. That's good. And I should multiply this by the bottom's reciprocal, which is 52 now on 329. Yeah, these are, whoops, 52 on, these are some unruly numbers here. So, let's see what we have. Okay, so writing down below here, we can view 329 squared as 330 minus 1 quantity squared, which should be something like 330. This is just my own thoughts on it. 330 squared should be minus 659, I think, if I treat it like that, which should be, let's try 108,241. Okay, so that's this value here. I'm just thinking out loud. So 108,241 sounds reasonable. Okay, now we have 104 squared. 104 squared should be 10,816. Okay, but I'm multiplied by 10, so this will be an add. Sorry about this, a little confusing note here. 10,816, 0. 10,816, 0 sounds reasonable. All right. And this 52 can cancel with one of these 104s, which is good, and leaves us a 2, if that makes sense. Right? I can do that. So that's very helpful. And so we'll have 2 times 104 times 329, and I don't have to worry about multiplying by the 52 anymore. All right, so we're almost there now. So the numerator should be, it's just a simple add, it should be 216401. 216401, if I looked at it right. And then the bottom, a little troublesome, but I'm going to treat it as 104 times 6, was that 658? 658. And if I think about it carefully enough, 216401, the bottom should be something like 684, I think. All right, so if you calculate this in the calculator and you get the decimal, I have a feeling this decimal will compare nicely to at least 4 places with the square root of 10 original, and so this is where we would stop the problem. Right? This should have 4 decimal places of accuracy.